So welcome everybody to this live demo. It's about smart contract development and especially how to pass multiple arguments in the functions of your smart contract and how to handle this smart contract storage. So we have 3 topics, and after each topic we'll answer some questions with some other people from the innovation team. I am the Sebastian from the innovation team, and we can start. So first of all, let's talk about some context of a transaction in the Massa blockchain. So in the Massa blockchain, when you interact with a smart contract through, for example, a decentralized application, the client, which is Massa Web 3, will create the transaction and submit the transaction to the node. Then the node will start a WebAssembly module and execute your smart contract. And for the input, it will be in binary format, it will be bytes. And the data in bytes or what smart contract you want to call, what function you want to call in that smart contract, and what are the arguments for that function. Then the WebAssembly module will execute your contract, and if an error occurs, the error message will go back to the node, and the node will emit an event with that error message, so that you can debug your smart contract, because you will be able to get this event from the Massa client. So, the 3 topics of the day is result, args, and storage. So let's start with the fact that in assembly script, which is a programming languages that we need to program with WebAssembly module, in this programming languages, which looks like TypeScript, we cannot handle errors with try catch. There is no such keywords, and each error will panic. This means the assembly script process will interrupt it, and the error message will go back to the node, and of course the transaction will be reverted. So the consequence is that if your code runs into an error, for example, any runtime error, out of range, an assert that is false, it will panic, and all the process will be interrupted. So it's not very convenient for developers. So you need to handle all errors by hand. This is why we introduced the result class. In this class, you can wrap a result of a function. It's like a wrapper around the result. And you can check if the result is okay. And it will return true if there is no error. And then you can expect or unwrap, use those 2 functions to get the actual value, the underlying value of your result. So let's see with some example. Here, we are creating a new result that wraps the number 17. Then we check if it's okay with this method, is okay. And if it's true, we unwrap the function with that method. It will return the underlying value, which is 17. If it's not okay, unwrap will panic, and all the process will be interrupted. This is why we recommend to use is okay only if you are sure that it's okay, because the error message will not be very clear. On the other hand, you can use the expect function to specify a clearer error message. It's our second example. Here we create a new result with a second argument, which is the underlying error message. And when we call the expect function, it will panic with that specifying custom error message here. And if you expect a function which you use expect, and if it's okay, then you will get back the underlying value, like the unwrap function. Okay. Do we have some question for now? I don't see any question in the question tab, so I wait a bit. If no question, I will continue. I will, yeah. So cool. So I'm just waiting a bit and we continue. So I think we can continue. No questions so far, so good. Second topic is about function arguments and return value. So for example, if you take the example of a hello world, we want to give a string for argument of our function from the Massa client. The node will always give to the function one argument in a binary format, because WebAssembly module can only interact with the outside world with native types and pointers, string pointers or byte pointers. And in Massa, we choose bytes because we can handle any kind of data, and it's more optimized for the serialization, because you need to convert from native types like string and numbers into bytes. This process is called serialization, and then in your smart contract, the first step of your smart contract is to deserialize the argument. And for this, we build some tools. But for example, if you have worked with Ethereum, you don't have to handle this, because the Ethereum virtual machine doesn't work like the Massa virtual machine, because actually the Massa virtual machine is a WebAssembly module, and it can only interact with native types and pointers. So we need to serialize all arguments, function arguments. And also the node will always provide one argument to the functions of your smart contract. So the consequence of that is that each function of your smart contract must have this signature. First of all, you export your function, then you call your function with the name you want, and the node will always provide one and only one argument. It will be in binary format, and in assembly script, we choose to represent binary format with this type, static array U8. For the second argument, for the return value argument, you should also use this type. So it's not very convenient for developers to handle this serialization by hand. This is why we introduced the Args class, which is like a serialization, deserialization process. You have the add method that will serialize the argument, and then you have the next functions. You have one next function for each native types, string, I32, floating point number, and so on. And next is a kind of a deserialization, so it can fail. This is why it returns a result that wraps the underlying encoded value. So if you want to use this Args class, you must install this package, MassaLabs AS type. And if, for example, your function doesn't expect any argument, you can use the shortcut no args in the call function of the SDK. So let's see with an example of a sum function. So this function follows the signature we saw just before, one and only one argument, static array U8. In the first line of the function, we simply create the instance of the args class, new args, and we give the passed bytes. Then here we have an args, and we call here the next I32 to get the number. We have here a result, so we expect the result to be okay. And if not, we are providing a clear error message saying that argument A is missing or invalid. Because, for example, if from the client side you serialize a Boolean value, then the next I32 will fail. The serialization will fail. So this is why here we are specifying that argument A is missing or invalid. We do the same thing for argument B. So we have now variable A and variable B. And then we return the value. And for that, here we choose to use args also to serialize the value. So we create a new args. We add the value we want to return, A plus B, and we call the function serialize. So that will return a static array U8, which is expected. And from the client side, we'll be able to deserialize this value and get the result. Cool. So do we have any questions? Don't hesitate. We'll wait for some seconds. Okay. So I guess we can continue with the last topic of the day, which is storage of the smart contract. So each smart contract have a persistent storage. And this storage is a key value mapping in binary format. So binary format in assembly script, as we saw just before, it's static array U8. So each record in the storage is composed of a key that points to a value. And the value is also encoded in bytes with static array U8. So each low-level functions of the storage of the SDK needs to interact with this type. It's not very convenient. So this is why we developed some high-level function for the SDK, for the storage functions. And we choose to use generic types to be able to provide different types into the storage functions. Storage functions are, for example, set, get, but we have also has, and some others. So in that example, you can provide as a key a string and also a key as a value, a string as a value. And when you want to get back the value, you put the exact same key, and we have here a string. And the serialization process is done at a low level. So here for developers, it's more easier. Now, what happens if you want to serialize multiple data, for example, two numbers? Then you can use Args to do this. Here, in the second line, we create a new Args and we add two values. We add 7 and 13. We pass this variable in the second argument of the set function, which is for the value of the storage record. And because this variable is type arg, it also needs to be args for the key. This is why here at the first line, we simply wrap the string key into an args. Now, when we want to get back the value, we put the exact same key, and we end up with an args. And to an args object, like we saw, we can use the next function to get the value as a result and unwrap it. So here, 7 is a I32 number, and 13 also. So this is it for today. Thank you for listening, and I will answer some questions if there is any. And so if we need to store a string, each character is an array element. Yeah, I can do. This is what storage set get does behind the scene. Storage set get can accept multiple types. It can accept as arguments strings, args, and directly static array U8 to let developers under their own serialization process. So tell me if it's answered your question. This is because I don't understand each character is an array of element. Actually, a string is an array of one character, and at a low level, it will convert it into static array U8. This is serialization. Okay, so static array in assembly script is a type of an array, and U8 here it's to specify what type of element of the array you will have. So U8 is a number encoded into 1 byte. So static array U8 is simply an array of numbers, and one numbers represent 1 byte. Yes, the U8 is like uint 8. So, yeah.
Everyone is so quiet.
So don't don't hesitate to ask questions. Now we have a few.
Yeah, don't hesitate to ask questions, and the goal is also to do like very like way shorter live coding sessions, just to explain a bit like the things which are being used and usable. So yeah, instead of having a too big session when there is like too much to understand and to learn. So that's why also it's shorter, so you have also more time for your questions. If there is no more question. Let's wrap it up.
Yep. Yes, I guess we can. So thank you everyone for listening.
It was a first time we use a new platform, so we hope you like it. It's to make it more understandable, to share documents, to use polls, to have a better like organization for the questions. Thanks a lot to Nathan for this presentation. And again, like the goal soon like is to have more and more, so you can ask always your questions, and don't hesitate also to propose some topics you would like to cover. Because we know also a lot of you like might have questions for some of the projects and so on. So I think the INNO team and the core team will be happy to have specific sessions if there are some topics which are unclear to you. So thank you, Nathan. Thank you, everyone. Wish you a great day. We'll upload the presentation on YouTube and speak to you later. You might receive invitation for the next one. So thanks again. Bye-bye.
Goodbye.